All right, so for excuse me, for lesson 4.3.3, this lesson is about correlation versus causation. We talked in the last lesson 4.3.2 about how to calculate the correlation coefficient and what it means. I'm not going to read everything to you, but I will hit on a couple of key points. So correlation between two events simply means that there's a consistent linear relationship between the two events. In other words, as one thing changes, the other thing changes. They seem to travel together, but they don't necessarily, one doesn't necessarily cause the other one to happen. A correlation does not imply causation. Causation would be one of the variables specifically causes the other variable to happen. Okay, it's not just a trend or a similarity. So, for example, researchers gathered data below comparing the hours of television watched by viewers and the viewers' weight in pounds. So, obviously, this is a very strong linear correlation. Okay, you can see that linear function growing. Your weight is increasing based on the number of hours you watch per day. Now, if you just read that and think about it for a second, you might say, well, sure, okay, that makes sense. Or another person might sit there and think, no, that doesn't make any sense because I watch a lot of TV and I weigh 100 pounds. And, my best friend, she doesn't watch TV or he doesn't watch TV and he or she weighs 100 pounds, right? So it all depends on who they're polling. First off, where did they pull this information from? And are there any other outliers or any other things that could be affecting this data? For example, if you're spending, 10 hours a day watching TV, then you're probably not getting a lot of exercise. And that, lack of exercise can, affect your weight in pounds. Or if you're watching that much TV, maybe you're eating a lot of junk food. You see, there's a lot of what ifs. There's a lot of additional information that could affect it. Just literally sitting in front of a TV does not affect your weight. Just that thing, right? Because you could sit down and watch TV, or you could get on a treadmill and watch TV, and that would have a very different impact on the weight in pounds, right? So your hours of watching television is not a direct cause of going up in weight. Okay, so even though it's a very, very, very strong correlation, there are other factors that means you can't assume causation. Okay, so I don't really want to read all this to you, but here's basically them explaining that same sort of process. So if you're looking for other information or a different way of saying what I just said, here it is. Knowing the difference between correlation and causation is particularly important when reading advertisements or other persuasive materials, right? They may show you that things are related, and when you go in and think about them, there are other factors that contribute to their correlation, to the effect where one thing may not be causing the other one to happen. All right, so let's look at some examples. Correlation does not automatically imply causation. If a change in one event is responsible for a change in the other, then there is a causal or causation happening. Outside factors may influence and explain a strong correlation between two events. And then, just like last time, use the calculator. Now, for the sake of time here, I'm not going to go through and redo how to calculate the correlation coefficient. We're just going to talk about them a little bit. So example one here. Alex coaches basketball and wants to know if there's a relationship between the height and free throw shooting percentage. Free throw shooting percentage is a number of free throw shots completed divided by the number of free throw shots attempted. So basically, the idea here is that there's a correlation between the height and the free throw shots made, where the taller you are, it would seem you seem to make more shots or less shots, right? And the correlation coefficient, if you calculate it, it's about negative 0.7. So it's a fairly strong correlation, negative correlation between your height and your free throw percentage. But what we really want to talk about is, does your height directly affect your ability to shoot a free throw, right? Or are there other factors? So it seems to me that no, there's not causation here, because if you had two equally skilled players, right, who are of different heights, but they have an equal skill level, they should have a relatively similar, or probably the same, or roughly the same free throw percentage. The height does not affect your ability to shoot a free throw as much as your skill level does. Okay, think about the NBA. There's some very tall players that are not good free throw shooters, and some very short players that are relatively short, for the NBA. So no, your height does not have a direct effect on your free throw percentage. Okay. All right. And that's all we're going to do with that. We're just, again, we could calculate and do the correlation coefficient, but I'll tell you, all of these have a decent correlation coefficient. It's going to be decently strong correlation, because what we're trying to decide is there causation for these correlations? So, Mr. Gray's students are interested in learning how studying can improve test scores. Mr. Gray provides students with a practice problem related to a particular test. The class records the number of practice problems completed and the score on the related test, and say below, what is the correlation? So there's a pretty strong correlation here between the number of practice problems completed and higher grades on the test. And it's a positive correlation. If you calculate it, it comes out to roughly 0.9, right, or 0.94. So it's a very strong correlation. And the idea here is the more practice problems that were completed, the higher your test score would be. And you can ask any teacher, especially a math teacher, like me, who would tell you that yes, there is definitely a causation there. Okay, it's not required that you complete a bunch of problems to improve your test score, but in general, the more you practice a skill, the better you will be at that skill, as long as you're getting, feedback from your teacher, and as long as you're getting correct answers. So the more practice problems you do, the more likely you are to get that type of question right. So yes, that is a direct causation. Okay. Now, example 3, they've already given you the scatter plot here. Salesperson, she notices the more hours she works, the more money she earns, right? And so the question is, do we think there's causation there? And think about a car dealership. Just because you spend more time there, you're more likely to pick up more sales. But depending on how many people are actually showing up at the dealership, because, let's say it's the time of year, let's say it's 30 degrees outside like it is this morning. In winter, you're not getting a lot of people. It doesn't matter whether you're there or not. Not a lot of people are showing up to buy cars because they don't want to be outside walking around looking at vehicles. So, there are outside factors that change that, right? She could also be there for 10, 15 hours a day, but if she's sitting in the back office, not out on the lot, trying to meet customers and talk to customers, then she's not going to make a lot of sales. So the hours in the day don't directly affect her income, because really the number of sales and the cost of the vehicles that she is selling has a greater effect on her income, not just being at work, right? Because she gets paid based on how much stuff she sells. Okay. So no, the hours in the day are not a direct effect on how much money she earns. They simply provide her with more opportunities to make more money. So that would not be causation. One last thing I'll say is a lot of science stuff, you can prove causation, right? So a good example would be like tobacco products and causing cancer, right? Because, it's been proven by science that using tobacco products leads to an increase in the number of cases in cancer. Smoking cigarettes and lung cancer, for example. There's a lot of research to back that up, to say that, yes, this definitely causes this other thing. Okay. So anytime you got science or something where it's proven that one thing causes the other, a certain type of food increased cholesterol or something like that, those are good examples of causation. All right. So good luck with that. This is more of a definition-y sort of thing. I would think about causation towards like a word problem type thing. Does this correlation show causation? Da 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 da. All right. Good deal.